Welcome to Lunchbox Sessions, bite-sized industrial training.
Hello, this is Carl from lunchboxsessions.com. In this video, we will look at a simple model for controlling the direction of flow and the flow rate from a variable displacement piston pump. In this case, it is a pump that is typically used in a closed-loop hydraulic system. A closed-loop hydraulic system is sometimes referred to as a hydrostatic system and is popular for operating hydraulic motors that propel a mobile machine such as a skid steer loader both forwards and backwards. The internal pumping elements, the rotating group made up of pistons in a cylinder barrel, are shown here using the simplified circle symbol. The long arrow cutting through represents the swash plate in the piston pump. Changing the position of the swash plate will represent changes in flow direction and flow volume. Varying the flow in a piston pump involves changing the stroke length of the pistons. This is why the valve that varies the pump displacement is sometimes referred to as a stroker or a stroke controller. The direction and displacement of a closed-loop piston pump is handled by a servo mechanism. A servo mechanism is basically any self-correcting control. The system needs to correct any time the operator requests from the pump a different output than what is currently being delivered. When the operator requests pump oil flow for forward propulsion, a small amount of current is sent to one of two solenoids on the servo valve that is typically mounted to the pump case. The current moves the spool that allows the servo pressure to enter the extend port on the control piston. The control piston moves the pump swash plate on stroke at a minimum flow rate. As the control piston moves the swash plate, it also moves the valve body to catch up with the internal valve spool position. As the valve body catches up with the spool, the valve closes and the control piston motion ceases. When the control lever is pushed further forward for a faster forward propel speed, the current to the solenoid is increased further. The valve spool opens once again, allowing additional servo fluid to enter the control piston and extend it further, increasing the swash plate angle. Increased swash plate angle results in a longer piston stroke and higher flow rate from the pump's right-hand port. Decreasing the current allows pressure in the control piston to be vented gradually to tank. Moving the control lever past the center point causes flow to be displaced from the pump's left-hand port. Our skid steer loader is now in reverse. This is a simple model, as stated earlier. In an actual displacement controller, there are more working parts and functions than what are shown here. But this simulation gives the general idea and gets the learner ready for more complete and more complex models that we will look at in future videos. Thanks for watching.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up. Get started at lunchboxsessions.com.